Before we're ready to finish up this module and kind of finish off Homo erectus and Homo ergaster here, we do have one more thing to really focus on, which is one other hominin species that's also around this, living around 1.8 million years ago, and that's Homo georgicus. And Homo georgicus is found at the site of Dmanisi. You can see it in the photo. It's labeled in red at the bottom of the photo, and it's found in the Republic of Georgia, which is between Turkey and Russia. And it's the only known site of this species. But this species is really important because it kind of messes up our entire understanding of leaving Africa. So I gave you in the previous lectures, I kind of gave you the standard story, the standard narrative, the still dominant narrative. But now in this short lecture, we're going to kind of sprinkle in some little problems, sprinkle in some little things that make it a little more difficult. So what we think in the simplest way is that Homo georgicus, it dates to about 1.8 million years ago. So the simplest story and the simplest explanation for this rando species is that Homo ergaster leaves Africa, finds their way in the Arabian Peninsula, and then goes north into the Republic of Georgia, stops there, sits there for a while, becomes reproductively isolated, becomes this new species, Homo georgicus. Then Homo georgicus continues to move east into Asia and becomes Homo erectus. Now, if this is the true story, that just means that a lot of evolution is happening in about a 200,000 year span. Is that impossible? No. Is it the most likely? It's a little surprising, but it's not impossible. But at first, this seems like one potential about what Homo georgicus represents, because it looks like ergaster and erectus, but it does have some of its own physical weirdness going on. And the one thing, though, that kind of makes a lot of this seem real strange, though, is that it does have a lot of those derived erectus or ergaster-like characteristics. But in a lot of other ways, it also looks like pretty primitive. And when I say primitive, I'm talking like Homo habilis. So one of the things is that it has still a very small brain. Its brain is much smaller than Homo ergaster or Homo erectus. Its brain is kind of like a Homo habilis brain. It's got a small skull. It's got a small brain. Its facial features are very robust, like we saw with habilis. It's got that facial prognatism that habilis still had, but Homo ergaster had mostly gotten rid of. It's got long upper limbs that still look very primitive and Australopithecine-like. Remember, Homo erectus, Homo ergaster, they got rid of those long arboreal arms, but Homo georgicus still has them. However, it also has pretty long legs that look really modern. Its spine and its thorax look very ergaster-like. And it has large molars, which looks very primitive. So what we're getting here is a species that looks very primitive. So if what happened was Homo ergaster leaves Africa, becomes Homo georgicus, and then becomes Homo erectus, we have to somehow explain that Homo ergaster leaves Africa, somehow becomes more primitive like Homo habilis, then moves into Asia, and then converts back to being more derived like Homo ergaster. And if you have to rewind that and listen to that a couple of times, I totally get it, because it's kind of confusing, right? You have a derived Homo ergaster becoming a primitive Homo georgicus, evolving into a derived Homo erectus. That's weird. And that's not really how evolution works. And so it kind of baffles the brain a little bit. Now, what this could suggest is that maybe the story of us leaving Africa was a lot more convoluted than we thought. Maybe this primitive mix of evolutionary traits means that Homo georgicus actually is more primitive than Homo ergaster. So maybe Homo habilis is the first to leave Africa and they just move into Southwest Asia, right? And they're not there for very long, which is why we don't find them very much. But some populations do evolve into Homo georgicus, where they get some of those more derived features that georgicus has, like those more modern lower limb bones. Then Homo georgicus, rather than moving into Asia, comes back into Africa, evolves into Homo ergaster, and then Homo ergaster leaves Africa again and then evolves into Homo erectus in Asia. That's kind of messy. But it's evolutionary time, right? Like this is happening over hundreds of thousands of years. And this might mean that Homo habilis left Africa earlier than we thought, possibly 2 million years plus. We just don't have any fossils in Southwest Asia. That maybe Homo georgicus, the specimens we have are 1.8 million years ago, but maybe they're older than 1.8 million years ago, which would give them time to come back into Africa and finish evolving into Homo ergaster by the time we actually have full-on Homo ergaster specimens. This is just a theory. It's just a proposal that maybe Homo ergaster was not the first to leave Africa, but maybe it was Homo habilis. But this is why Homo georgicus is important. Even though there's only a few skeletons at one site, this is important because it might change everything we know about leaving Africa for the first time and the relationship between Homo habilis and Homo ergaster. So your options are either Homo habilis evolves into ergaster, which evolves into georgicus, which evolves into erectus, or habilis evolves into georgicus, which evolves into ergaster, which evolves into erectus. And I'm simplifying it. Remember, it's branching. It's a tree. It's not Pokemon. I'm just simplifying it to explain it. But these are really your two major options. There's one other really cool thing about georgicus that I do want to bring up, though, as you're all trying to process what all this means, which is that one male specimen that we have from Dmanisi actually has tooth loss. And the tooth and the bone became resorbed. So we know that he didn't die from it. But because of the tooth loss, he would have been less good at like chewing food and like just surviving. And so this might be the earliest evidence that we have of like humans doing reciprocal altruism. In other words, somebody had to help him survive. Somebody had to help like, take care of him when he was dealing with a big major tooth infection. Somebody had to be like, taking care of him and doing all this stuff. And this is the first evidence we have where it wasn't just like most animals, where it was like, you're dying, see you later. But it was literally like, we're actually going to take care of you because we care about you. And this might have evolved here in this like weird 1.8 million year period. But I just wanted to talk about that really fast. This was just like kind of like a little epilogue to the erectus ergaster story. So that's going to pretty much wrap up this module. And then in the next module, we'll continue talking about further evolutionary happenings, particularly focusing in Europe, since that's where we haven't talked about yet. And that's because Europe is also kind of a mess in terms of us trying to understand what's going on there. But we'll get to that in the next module.